So in an electric guitar, there's a thing called a pickup. Now, essentially what a pickup is, it's almost like an electric generator. It creates a magnetic flux, and then the motion of the strings on top of the pickup, it generates a signal which the amp then reads, and it produces sound. Now, this signal depends on the amount of coils or turns of wire that's around the pickup, and it also depends on the strength of the magnet which is attached to the pickup. So what I did was I took an iron nail and I wrapped a copper wire around it, coated copper wire, about 205 times. I say about because it's hard to count the coils as you wrap it around, but it's about 200 turns on that nail. And then I took about a 1 Tesla strength magnet and stuck on the end of the nail. Then what I did was I connected it to my amp, and this is the result. Okay, so one of these videos wouldn't be complete without trying to calculate something. So I tried to calculate the magnetic flux created by the pickup that I made. So the magnet that was on the end of the nail was about 1 Tesla in strength, but the pickup wasn't feeling the full strength of the 1 Tesla. Because it was a distance of at least 6 centimeters away from where the string was actually passing over, because that was the length of the nail. So I used a magnet, used a compass, and tried to figure out the strength of the nail, the magnet connected to the nail. And the magnet moved about it moved 285 degrees. It didn't make it all the way around, but it moved to the left. So instead of subtracting, I just took the tangent of 285 since it's the same over. Anyway, then I multiplied that times the magnetic field of the Earth, and I got that was 6.155 times 10 to the negative 5 Tesla. And then I I calculated the strength of the magnetic field generated by the solenoid that I created, the electromagnet. K is the permeability of the core. For iron, it's about 200. And then I have the turn density, which is the number of turns over the length of the electromagnet, and then times the current that was going through it. Now my amp produces a current of about 500 milliamps, so 0.5 amps. So multiply all that together, and it's approximately 0.429 Tesla. So then calculating the flux, we get that the area never changes, but the magnetic field changes. So if we subtract those two fields and then multiply by the area, I took the area of the top of the nail because that's where the field was coming out of, and I found the radius to be about 0.5 centimeter. So I got that the flux was about 3.367 times 10 to the negative 5 decimeters.